So now that we know that, remind ourselves what the components of classes are, uh, where are some situations might they be useful for simulating things? Let's say that you and all of your friends are playing this chess simulator, or this chess video game that's online. And maybe you have a class for every piece, like the knight in chess. You're eventually going to make some objects of the knight, which are the actual copies that exist. And a chess game has four knights, two on one team and two on the other. So it makes sense that we might have my knight one, my knight two, your knight one, and your knight two. Every knight is going to have some information that it saves, which is its variables, like the X position and the Y position. There's going to be a constructor that creates the knight at the beginning of the game and gives its initial position. And then maybe the knight each has some moves that it can use, like get its position or take a piece or move to a different place on the board. This is essentially what we're doing, is creating these blueprints that we can use in different situations. Let's say we're creating a traffic simulating program. Think about where each of the following of these might be useful in a traffic simulation program. What might we use each of these components for? Go ahead and pause the video and spend about 3 minutes with your partner thinking that through. I came up with the following examples. So the class for a traffic simulator, maybe we can make a blueprint for a car. That's something that might exist. And a traffic simulation is probably going to have multiple cars. So those are going to be the objects. Maybe it has some methods like get passengers, get license plate, drive, brake. These are the jobs that we might have a car do. Maybe it has variables like string, right, license plate, or an integer that represents the year, or a double that represents the number of miles. And then maybe it also has a constructor which creates the car inside of the simulation in the first place with its initial values of whatever that license plate number, the year, and the miles are going to be when you start running the traffic simulator. So all this is just kind of a conceptual reminder of the stuff of the different components of a class that we learned about last semester. And I just kind of want to take a brief look at their implementation over the course of the next couple minutes. Remember, we are going to have to use methods when we work with constructors or we work with classes. So let's actually start with just a little bit of a conceptual review of methods. We have a class here that has a main method. And it has two methods that exist within the same class: public void p string a, public int mold3. Take a couple minutes, pause the video, think about how many arguments each has. And I would love if you could write the method call, write the code to call the methods inside of this main method up here, just to remind yourself of how to do that one more time. Pause the video here and then kind of do that with your friend for a second. So this is a method we talked about all the way back in October, which is the P method, courtesy of Lawrence McKinney. It's a really easy way to print something out. Its return type is void, as we see here. So we can actually just go up to the top and call P and then whatever we want to print out. And this is void, so it's just the method name and the arguments. And this takes in one string, which is A. If we look at the mold3 method, that'll take in 3 arguments, A, B, and C. And so maybe this multiplies 2 numbers like 2, 3, and 4 together for us. And it returns an integer. So as a reminder, we have to write int result equals in front of it because it returns an integer return type. So that allows us to call a method within an existing class, and calling methods is something we're going to work with a lot tomorrow. So it's just kind of a good thing for us to recap. Okay, last thing that we want to do is look at a class, which we've done before. And we mentioned that classes have variables, constructors, and methods in them. I would love for you to pause the video for about 2 or 3 minutes and identify where the variables, constructors, and methods are in the student class. And then notice that this doesn't have a main method. See if you can explain why that's the case. Then unpause the video when you're done. If we look at this class, the student, maybe we want to run a student simulation. We appear to have the variables appear at the top, like student ID, name is senior. Then we're looking for the constructors. Anything that a method with a name of the class is a constructor. And the remaining components that have return types are kind of the standard methods of this class. So if we create a student, it'll be able to update its name, show its honors earned, and we can get its student ID. Now you will notice that it does not have a main method. The reason for that is because when a class blueprint is created, objects of the class are made in a different file. Take a look down here on page number 4, and you will see that there's what's called the student runner. We've been working with runner classes all year. This is where students are actually created, and we call their methods, we update their names, we get their student ID. Notice how I'm using an object on a method here. We'll remind ourselves a little bit about how to use methods tomorrow on particular objects. But what I want you to understand is that when I make a blueprint like this class, then I use it in another file, which has a main method, which is what my student runner is doing here. We don't have any homework due tomorrow, but you will have a syntax quiz on Thursday on this material. What I'd like you to do before you leave is I just told you about the relationship between the student class and the student runner, using all the as many vocabulary words as you can from what we've done today. Go ahead and answer that in this box, and you can go ahead and submit. This is just a good recap, and we'll talk about a few of these things tomorrow. Thanks for your hard work, everybody.